Any more about that?
Yeah, that's easy. Because I'm in this business field for so long, I appreciate the fact that this is potentially one of the toughest diseases to treat. Losing your dystrophin from your cell membrane is a catastrophic change that causes all kinds of intracellular events. And this is kind of like spitting in the wind at a big giant monster. And so there have been I've just seen too many drugs come and go that have been this type of spitting in the wind. So you're sort of repurposing a drug that may be used in heart failure and saying, well, could it be used in this patient population? In some regards, I guess. And that's very naive, I think. So I think of this as, it looks like a repurposed drug that is a little naive with regards to the disease process.
Yep.
But I may be one of very few cardiologists in this country that would say that, but I've been at this for so long, that's what it looks like to me.
No, this is exactly what's useful and helpful. Are there outcomes that would make you consider its use? And that there's a reason that there are, that's XYZ for the improvement percent, because what I want to know is what percent improvement would be of interest, not is this little bit of interest, but when would it be, or if at all, would you need to see for this product to be exciting?
Well, okay, so that's actually a really good question. So ejection fraction is such a variable endpoint, right? It depends on volume status and heart rate. There's so many things that impact your ejection fraction, right? And so a very frustrating thing to me is when a family comes in and the EF was 55%, and then we re-image them a year later and it's 65%. And so all of a sudden the family's like, yeah, those drugs work. No, I mean, like, those are both normal ejection fractions, right? That's why there's this range. So what would be an impactful change in ejection fraction is a pretty significant change in your EF, which I have seen literally a lot. Gosh, I've been doing this for a long time. So it's very difficult to impact an EF in a positive direction, because once you lose myocardium, it's not coming back. You're just whipping it a little bit more, right? And so I have, even when let's say I have a kid with an EF of 45%, and I increase the ACE inhibitor, and I start him on a high-dose beta blocker, and I put him on a Plerinone. My goal is to keep them from deteriorating and not changing their EF in a positive direction, because I never see it get better. Never, ever, ever. Unless we're talking about the 45 to 50 change, right? And people go, oh, yeah, they said it was 45 last time and it was 50 this time. Yay! I'm like, that's not really okay.
Yeah, which is not meaningful.
Yeah, it's not meaningful change. That's just variability of measurement, right?
Yep.
So in order to see change on a cardiac MRI, one, the disease is so slow with regards to disease progression. I think this has been a tremendous barrier for us designing clinical trials, because we have to follow these kids or these patients for 5 years to see this, right? Because there's a lot of variability.
And that was another question I had, right? Yeah, how long would you need to follow this?
Yeah, 5 years. These are 5-year clinical trials. And so this kind of takes you back to the initial question. So why don't we know if ACE inhibitors are truly of benefit? Because I've sat and planned out those clinical trials. We're going to start an ACE inhibitor, everybody at age 4, and then we're going to keep an eye on them for the next 5 years. Well, that's a $40 million trial, right?
Yep.
Who cares, right? I mean, I don't want to spend $4 million to know if an ACE inhibitor is beneficial to your myocardium, because it probably is,